Hey everyone. Ever get that feeling like we're just scratching the surface of something massive?
Well, you're right. When it comes to the Earth, I mean, literally.
Exactly.
Right.
Today we're going deep, really deep down into the Earth's core.
And not just the basic stuff you learned back in school. We're talking about mind-blowing facts and discoveries.
We're basing our deep dive today on a fascinating episode from the Science Unlocked podcast.
Yeah, it's called Beneath Our Feet.
It's all about the Earth's core.
And believe me, it's way more than just, oh yeah, it's hot down there.
So before we get into the nitty-gritty, can you give us a quick overview of what we're dealing with here?
Sure, basically imagine this. A sphere of solid iron, bigger than Pluto.
Whoa, bigger than Pluto.
Yeah, and it's surrounded by a swirling ocean of liquid metal.
Okay, hold on. I'm already getting some sci-fi movie vibes here.
Well, truth is often stranger than fiction, right? And that's just the beginning.
I'm all ears.
The core isn't just one big lump of metal,
There's more.
It's actually divided into layers. You've got the inner core, which is solid.
Solid, but how can it be solid with all that heat?
It's the pressure. The pressure down there is so immense that it forces the iron into a solid state.
Okay, that's pretty wild. So what about the other layer?
The outer core, that's the liquid part. A swirling, churning ocean of molten iron.
Okay, this is blowing my mind. We've got this solid iron heart surrounded by a sea of liquid metal, all deep beneath our feet.
It's pretty incredible, right? And it gets even more fascinating when you consider how we know all this.
Yeah, we can't exactly send a submarine down there to check it out.
It's true. But we have another tool, seismology.
Earthquakes.
Not the earthquakes themselves, but the waves they produce.
Seismic waves.
Exactly. By studying how these waves travel through the Earth, scientists can figure out what kind of material they're passing through.
So like an X-ray of the planet.
Pretty much. And those X-rays tell us that the core is mostly iron and nickel, with a few other elements thrown in.
Iron and nickel, those are heavy metals, right?
They are. In fact, the core is incredibly dense. Way denser than the Earth's crust.
So how did all that heavy metal get down there in the first place?
That's where we go back in time, about 4.5 billion years.
Back to when the Earth was forming.
Exactly. Imagine a fiery, molten Earth. Gravity pulled the denser stuff, the iron and nickel, down to the center.
So gravity basically sorted everything out with the heavy stuff sinking to the bottom?
Yeah, and the lighter stuff rose to the top, forming the mantle and crust.
It's amazing how gravity shaped our planet on such a massive scale.
It's a process called planetary differentiation. But here's the twist.
Another twist.
It seems the inner core didn't solidify right away. It took billions of years.
Our planet had a molten heart for billions of years. Wow. So how did it eventually become solid?
Well, the Earth was cooling down over time.
Right, and the intense pressure was always there.
Exactly. Eventually, the combination of cooling and pressure caused the inner core to crystallize.
So it was like a giant snowball rolling downhill, gathering more and more iron as it went, until finally, boom, a solid core.
That's a great way to put it. But there's more to this story, and it has to do with something we all rely on.
You're going to talk about the magnetic field, aren't you?
You know it, that invisible shield protecting us from harmful radiation from the sun.
But how does a giant ball of metal deep inside the Earth create a force field that extends far out into space?
That's where things get really interesting. It's all about the outer core, that swirling ocean of liquid iron.
So it's not just sitting there, it's moving.
Constantly. And the movement creates electric currents.
Electric currents from molten iron.
It's like a giant natural dynamo. And those electric currents generate the magnetic field.
Hold on. So we have this solid iron core surrounded by a swirling sea of molten iron that's creating electric currents.
And those currents create the magnetic field that protects us. It's pretty remarkable when you think about it.
It really is, and it's all happening right beneath our feet.
It's a good thing, too. Without the magnetic field, our planet would be bombarded with harmful radiation from the sun.
I've heard that Mars used to have a magnetic field, but lost it.
That's right. And without that protection, Mars's atmosphere was stripped away by the solar wind.
Making it the barren planet we see today.
Exactly. So we have our Earth's core to thank for making life as we know it possible.
This is all pretty mind-blowing stuff. So this incredible dynamic system deep beneath our feet. A solid iron core surrounded by a swirling ocean of liquid metal, generating a magnetic field that protects us from the sun's wrath.
And we're just getting started. There's still so much more to discover about this hidden world beneath our feet.
Well, I'm definitely hooked. I can't wait to dive deeper into the mysteries of the Earth's core.
Me too. We'll be back after a short break to explore some of the most intriguing questions scientists are trying to answer about this fascinating realm.
Okay, I think I've caught my breath after all those mind-blowing facts.
Pretty amazing stuff, right?
It really is. But I know we've only just scratched the surface here.
There's always more to discover when it comes to the Earth's core.
So where do we go from here? What are the big questions that scientists are still trying to answer?
Well, one of the biggest puzzles is the exact composition of the core.
We know it's mostly iron and nickel, right?
Yeah, about 85% iron, 10% nickel.
So what's the mystery then?
It's those other elements, the remaining 5%.
Like what?
Things like sulfur, oxygen, silicon. We know they're in there, but the exact proportions are still a bit of a mystery.
And why does that matter?
Well, think of it like a recipe. Changing the ingredients, even slightly, can change the final product, right?
Makes sense.
The same goes for the core. The proportions of those lighter elements can affect things like its density, its melting point, even how it interacts with the mantle.
Speaking of the mantle, we touched on that boundary between the core and the mantle earlier.
With its mountains and valleys of dense rock, yeah.
How do scientists even study something like that? It's not like they could just go down there and take samples.
True, but they're using some pretty ingenious techniques.
Like what?
Well, one way is by analyzing seismic waves as they pass through this boundary.
You mean the waves from earthquakes?
Exactly. As those waves travel through the Earth, they're affected by the materials they encounter. So by studying those subtle variations, scientists can start to map out the core mantle boundary.
So it's like using sound waves to create a picture of something we can't see.
It's a bit like that, yeah. And what they're finding is that this boundary is far from static.
What do you mean?
It's a dynamic zone with lots of interaction between the core and the mantle. And those interactions can have big impacts on everything from heat flow to the behavior of the magnetic field.
Okay, so we've got this complex dance happening between the core and the mantle, shaping our planet in ways we're still trying to understand.
It's a pretty amazing system, isn't it?
It really is. But you know what else I'm curious about? Those magnetic flips. We talked about them earlier, but I still have so many questions.
Like what triggers them?
Exactly. And what could happen to life on Earth if the magnetic field flips?
Those are some of the biggest mysteries surrounding the Earth's core.
And do we have any answers yet?
Well, scientists have a few theories about what might trigger these flips.
Like what?
Some think it could be changes in the flow of those convection currents in the outer core.
Those swirling currents that generate the magnetic field.
Those ones. Others suspect it could be something to do with interactions between the core and the mantle.
Or maybe even something from outside Earth, like solar activity.
That's a possibility too. But as for what could happen during a flip, well, that's where things get a bit uncertain.
Uncertain in a good way or a bad way.
Well, some scientists think that a magnetic field reversal could weaken our protective shield, making us more vulnerable to solar radiation.
So more intense auroras.
Potentially. And it could also disrupt satellites, power grids, even increase radiation exposure for astronauts.
Okay, now that's a bit worrying.
It's definitely something scientists are keeping a close eye on. But it's important to remember that these reversals happen over very long periods, thousands of years.
So it's not like our compasses are going to go haywire tomorrow.
No, definitely not. But understanding these flips and their potential impacts is crucial for understanding our planet.
It's all about connecting the dots, right? Seeing how the Earth's core, the magnetic field, even solar activity are all interconnected.
Exactly. And speaking of connections, we've touched on how studying our own core can help us understand other planets.
Yeah, that idea blew my mind. So are you saying that by looking deep inside Earth, we can learn about distant worlds light years away?
It's not that far-fetched. The processes that shaped Earth's core are likely similar to those that shaped other rocky planets, both in our solar system and beyond.
So by studying our own core, we're essentially getting a glimpse into the hearts of countless other worlds.
In a way, yes. And as we gather more data about our own core, we can start to apply that knowledge to other planets, piecing together their histories and even assessing their potential for hosting life.
That's incredible. It's like having a Rosetta Stone for planets. But I have to wonder, if we could somehow send a probe to the Earth's core, what would we find?
Oh, that's the dream, isn't it? Imagine a probe that could withstand the unimaginable pressure and heat, beaming back data about the core's composition, temperature, magnetic field, all in real time.
It would be revolutionary. We could finally get a first-hand look at those convection currents, study the core mantle boundary up close, maybe even solve the mystery of those magnetic flips.
It would be a game changer, for sure. but the technological challenges are immense.
I can imagine. Drilling through thousands of kilometers of rock and metal, designing a probe that can survive the most extreme conditions imaginable. It sounds like something straight out of science fiction.
It does, but who knows what the future holds? With advancements in materials science and engineering, maybe one day a journey to the core won't be just a fantasy?
I hope I'm around to see that.
Yeah.
But for now, we have other exciting avenues of research to explore.
Like what?
Well, you mentioned earlier that scientists are using some pretty sophisticated techniques to study the core.
We are, and those techniques are constantly evolving.
So what are some of the latest developments? What's giving scientists a clearer picture of the core these days?
One of the most exciting developments is the use of neutrinos.
Those ghostly particles that can pass through anything.
The very same. They're produced in the core through radioactive decay, and they can travel straight through the Earth.
So they're like little messengers from the heart of our planet.
That's a great way to put it. And by building sophisticated neutrino detectors, scientists can capture these particles and use them to map out the core's composition and structure.
So we're essentially using these tiny invisible particles to create a picture of something we can't see.
It's pretty amazing, isn't it? And it's just one example of how scientists are pushing the boundaries of what's possible to understand this hidden world beneath our feet.
It's mind-boggling to think that something so small can tell us so much about something so vast.
It's a testament to the power of scientific inquiry. But the journey to understanding the Earth's core is far from over.
I'm ready for the next leg of the journey. What else is out there? What other mysteries are we going to unravel?
Well, that's what we'll explore in the final part of our deep dive. We'll delve into the cutting-edge research that's pushing the boundaries of our understanding and consider the implications for our planet and beyond.
Sounds like a journey worth taking.
Yeah.
So buckle up, listeners, because we're about to delve even deeper into the heart of our planet. I'm ready to explore the future of core research. What do we got?
It's like we've charted the continents of this hidden world. But now it's time to explore the uncharted territories, you know?
I like where this is going.
Yeah.
What kind of uncharted territories are we talking about?
Well, one area that's really heating up, so to speak, is the study of the core's evolution over time.
The core's evolution.
Yeah, we know it's billions of years old, but how has it changed? Has its composition always been the same? Or has it been transforming over time?
So it's like a detective story, trying to piece together the history of Earth's heart.
Exactly. And by understanding how the core has evolved, we can start to answer some of the biggest questions about our planet. Like, how did the inner core solidify? Was it gradual or like a sudden event?
That's a good question.
Yeah, imagine the early Earth, a molten inferno, and then, bam, the inner core crystallizes, changing everything.
It's kind of poetic when you think about it.
It is, and scientists are using all these incredible simulations to try and recreate those conditions, you know, to see how it might have happened.
So like a virtual time machine, going back to the birth of the inner core?
Pretty much. And these models aren't just about the past, they can help us predict the future, too.
The future of the core.
Yeah, like how the magnetic field might evolve. Will it flip? When? What will that look like?
Speaking of magnetic flips, I gotta ask, those compass spinning events, what can actually happen to us during one of those?
That's the million-dollar question, right? It's a bit unsettling, honestly.
Unsettling how?
Well, some scientists think a magnetic field reversal could weaken our shield, you know, making us vulnerable.
Vulnerable to what?
To solar storms, cosmic radiation, all that stuff the magnetic field usually protects us from.
So, more intense auroras.
Possibly, yeah. And disruptions to satellites, power grids, maybe even increased radiation exposure for astronauts.
Okay, now I'm getting a little nervous.
I get it. It's a big unknown. But remember, these things happen over a really long time.
Thousands of years, right?
Yeah, exactly. So it's not an immediate threat, but we need to understand these things, you know, just in case.
So are you saying we need to start prepping for a magnetic apocalypse right now?
Not exactly. But understanding the potential impacts is crucial. It's about being prepared, right?
I guess so.
Yeah.
But let's get back to something a little less apocalyptic.
Sure.
We talked about how studying our core can give us insights into other planets, which is mind-blowing.
It is.
But how far can we take that analogy? Can we really learn about distant worlds by just studying what's under our feet?
I think so. The processes that shape planets are pretty consistent across the universe, you know? So by understanding our own core, we get this incredible window into how other planets form.
So it's like a universal blueprint for planets.
Yeah. And the more we learn about our own core, the better we get at interpreting what we see on other planets. You know, their history, their potential for life, all that.
It's like we're using our planet as a key to unlock the secrets of the universe.
Exactly. But let's shift gears a bit and talk about the tools scientists are using, all the tech that's pushing the boundaries of core research.
Oh yeah, I'm all about the gadgets.
Well, one breakthrough that's really changed the game is the use of neutrinos.
Those ghostly particles that can pass through anything.
Yep. And they're produced in the core through radioactive decay. So by building these super sensitive detectors, scientists can actually capture these particles and use them to map out the core.
It's like X-ray vision, but with neutrinos instead of light.
That's a great analogy. And then there are synchrotron radiation sources.
Those are.
Basically, they produce these incredibly bright focus beams of X-rays that let scientists study materials under extreme pressure and temperature.
Like a mini Earth in the lab.
Exactly. So they can recreate the conditions of the core and study how materials behave. Things like the core's magnetic properties, the dynamics of those swirling currents, all that.
It's incredible what science can do these days.
It is. But even with all this amazing technology, there are still so many questions we haven't answered.
Like what?
Well, one of the biggest challenges is understanding those convection currents in the outer core. The ones that drive the magnetic field.
Right, those swirling currents.
Yeah. We know they're there, but the details of how they work, how they interact with the mantle, all that, it's still pretty mysterious.
So there's still so much more to learn.
Oh, absolutely. And that's what makes it so exciting. The Earth's core is this frontier of scientific discovery with so much potential to reshape our understanding of our planet and the universe.
Well, this deep dive has certainly opened my eyes to the wonders beneath our feet. It's amazing to think that there's this whole other world down there shaping our planet in ways we're only just beginning to understand.
It's a humbling thought, isn't it? And it's a reminder that even though we live on this planet, we're still just scratching the surface of its mysteries.
I couldn't agree more. So to all our listeners out there, keep those questions coming, keep exploring, and never stop being curious about the world around you. Because as we've learned today, the most incredible discoveries often lie just beneath the surface.
And until next time, keep looking down and remember that beneath our feet lies a world of wonder, a world of extremes, a world that continues to shape our planet and inspire our imaginations.